Yes. Hello, good morning. My name is SAGAR. Now we are going to discuss about the P block elements. In that, sixth group elements. Sixth group elements we are going to discuss now. Okay. Sir, what are sixth group elements? What are sixth group elements? Sixth group elements are oxygen, sulfur, selenium, tellurium, polonium. Oxygen, sulfur, selenium, tellurium, polonium. Okay. Now see, these elements are called chalcogens. These elements are called chalcogens. Okay. Now we are going to discuss about the occurrence of these elements. Occurrence. Okay, or abundance of these elements. Now see, these elements are oxygen available in the earth crust. Available in the earth crust, 46.6% is present. How much? 46.6% is present. Oxygen available in atmospheric air by the volume. Atmosphere air by the volume. Okay, 20.946% is present. 20.946% is present. Okay, I'm saying this is the abundance of the oxygen. And the next we are going to discuss about the sulfur. Okay, sulfur is available in the percentage 0.1 to 0.203% is present. 0.1 to 0.03% is present sulfur. And sulfur is present in the form of sulfates. Sulfur is present in the form of sulfates. So those are first one, gypsum. Gypsum. Okay, this is gypsum formula CaSO4.2H2O. This is gypsum. Here you see sulfur is present. And sulfur is available in the form of Epsom salt. Epsom salt. That is the MgSO4.7H2O. Sulfur is available in the form of Epsom also. And the next, sulfur is available in the form of barytes. That is the barium sulfates. Barium sulfate, barytes. Means sulfur available in the form of sulfates, gypsum, Epsom, as well as barytes. Okay. Now, sulfur is available in the form of sulfides. That is the galena formula PBS. And sulfur is available in the form of zinc blend. Zinc blend formula ZNS. Zinc blend formula is a ZNS. And sulfur is available in the form of copper pyrites. That is a CuFeS2. So this is the availability of sulfur. Okay, right. Now we are going to discuss about the selenium and tellurium. These elements are available in the form of sulfide ores. In the form of sulfide ores or minerals. Sulfide ores are minerals. Okay. And polonium. What is that? Polonium. See, polonium is a radioactive element. Polonium is a radioactive element. Okay, which is uranium or thorium decay product. When uranium and thorium undergoes decay, then polonium will be formed. It is a radioactive element This polonium half-life is the 13.8 days. 13.8 days. Okay, so this is the abundance occurrence of sixth group elements. Okay, right. Now we are going to discuss general properties of sixth group elements. Sir, what are the general properties of sixth group elements? That is, first one, electronic configuration. Electronic configuration. Okay. In the electronic configuration, sixth group elements, general electronic configuration, NS2NP4. What is that? NS2NP4. Right. And second one, atomic and ionic radii. Atomic and ionic radii. Atomic and ionic radii down the group increases. Atomic and ionic radii down the group increases. Atomic and ionic radii down the group increases. And you see, in the size of oxygen and sulfur is a large difference. It will become large difference. Okay. And in this group, oxygen is the small one. It's a very small one, oxygen. Okay, right. And the next we are going to discuss about the ionization enthalpy. Pardon, what is that? Ionization enthalpy. Ionization enthalpy. Now see, ionization enthalpy of these group elements down the group, ionization enthalpy decreases. See, here the relation is that atomic radius increases, ionization enthalpy decreases. So atomic radii is inversely proportional to ionization potential. Atomic radii is inversely proportional to ionizational potential. Okay. Next here, one very important point. Already the point I discussed in fifth group elements. Ionization enthalpy. What ionization enthalpy? Ionization first ionization enthalpy of fifth group elements are higher than sixth group elements. First ionization enthalpy of fifth group elements is higher than sixth group elements. Why? Because fifth group elements general electronic configuration NS2NP3, sixth group elements general electronic configuration NS2NP4. It means that fifth group elements are having the extra stable half-filled electronic configuration. What is that? Extra stable half-filled electronic configuration is %. Due to this reason, fifth group elements ionization potential is higher than sixth group elements. Okay, right. So this is a very important point. And the next, we are going to discuss about the electron gain enthalpy. What is that? Electron gain enthalpy. Electron gain enthalpy. Electron gain enthalpy is these fifth group elements are follow this order: oxygen, sulfur, selenium, tellurium, polonium. Sir, one doubt, sir, first. Sir, what is electron gain enthalpy, sir? Yes. When an electron enters into the gaseous state of neutral atom, the atom which releases some amount of energy, that is electron gain enthalpy. Okay, electron gain enthalpy, these sixth group elements are large negative values. Okay, right. See, this Oxygen electronegativity minus 141. Sulfur minus 200. Selenium minus 195. Tellurium minus 190. Polonium minus 178. 174. 174 minus 174. So if electron gain enthalpy order, if you want to write, okay, so sulfur is the highest, then after selenium, then after tellurium, then after polonium, and last and least one is the oxygen. So this is the electron gain enthalpy order. So in this group, highest electron gain enthalpy element is that sulfur, lowest electron gain enthalpy is that oxygen. You remember. Why? Because oxygen is a small size. It cannot accommodate the electron. It cannot accommodate the place for electron. Okay, so that's why it's a very low. This is the electron gain enthalpy order. And the electron gain enthalpy down the group, this order is going to follow. You have to remember. Which order? Sulfur greater than selenium, tellurium, polonium, then after oxygen. Okay? Right. And the next we are going to discuss about electronegativity. Electronegativity. Yeah. Electronegativity. Electronegativity. In this electronegativity, down the group decreases. Down the group decreases. Electronegativity down the group decreases. But you remember, it's the total periodic table. Total periodic table after fluorine. Total periodic table, highest electronegativity element, fluorine. Fluorine. The next element is oxygen only, highest electronegativity. Okay, so oxygen is the second highest electronegativity element. Okay, so this is the electronegativity down the group decreases, and the second electronegativity element is oxygen. And the next we are going to discuss about some physical properties. Some physical properties. Some physical properties. So you see, physically how they are. Physical properties, physically how they are. See, here sulfur, selenium, tellurium, polonium, oxygen, sulfur, selenium, oxygen, sulfur, selenium, tellurium, polonium. Oxygen and sulfur, these are non-metals. Selenium, tellurium, these are metalloids. Polonium is a metal and radioactive elements. Radioactive element, and I told you it's half-life time, 13.8 days only. Half-life time. EF is how much? 13.8 days only. Okay, and you see, in this sixth group, all elements are exhibit the allotropy. All elements exhibits allotropy. All elements are exhibit the allotropy. Okay. Now see, oxygen is O2 in the form of O3 also is present. O2 and O3 also. Oxygen, dioxygen, and ozone O3 also in the form of O3 also present. Okay. And these all are polyatomic. These all elements are polyatomic. See, sulfur exhibits up to SAIT molecule. SAIT molecule exhibits polyatomic. Okay. And see, this melting and boiling point is increases down the road. Melting and boiling point is increases down the road. Okay, and you remember the important point in between oxygen and sulfur. Oxygen and sulfur, highest difference in melting and boiling point, highest difference it will become. The difference is due to the atomicity. What is it? Atomicity of oxygen as well as less molecules. Due to the large difference in the atomicity and the melting and boiling points of these two elements are large difference, it will become large difference. Okay, so these are the some physical properties. Now we are going to discuss about the chemical properties. Chemical properties. See, in the chemical properties, now we are going to discuss about the chemical properties. There is the oxidation state, trends in the oxidation state. Trends in the oxidation state. Trends in the oxidation state. See, one by one we discuss. Oxygen, which is exhibit -2 oxidation state. Oxygen exhibit which one? -2 oxidation state. But -2 oxidation state down the group decreases. Down the group, what happens? Down the group decreases. Okay, down the group decreases. Polonium hardly shows. Polonium hardly shows -2 oxidation state. Polonium is hardly shows -2 oxidation state. Okay, next to oxygen, it exhibits -2 oxidation state. But when oxygen is combined with fluorine in the form of OF2, in the form of O2F2, oxygen exhibits +2 oxidation state also. Oxygen exhibits +2 oxidation state. Here +2, here oxygen +1, positive charge also it will be exhibited. Only you remember, when oxygen is exhibit the positive oxidation state. When oxygen is combined with fluorine, then only it is exhibit the positive oxidation state. Then never it is exhibit the positive oxidation state. You remember. Okay, and see all these elements, common oxidation state. All these exhibit common oxidation state is that is the +2, +4, and +6. +2, +4, and +6. Okay, and very common oxidation state +4 and +6. Remaining elements except oxygen, remaining elements sulfur, selenium, tellurium, okay, exhibit +4 oxidation state when those are combined with oxygen. When other elements sulfur, selenium, tellurium exhibit +4 oxidation state means when they are combined with oxygen. When they are exhibit the +6 oxidation state means the sulfur, selenium, tellurium when they are combined with halogen, that too with the fluorine only. You remember. When these elements are exhibiting +4 oxidation state, sir, when they are combined with oxygen. When these are going to exhibit +6 oxidation state, when they are combined with fluorine. Okay, these oxygen state is exits. But anyhow, my dear students, you remember the important point is that plus 4 oxidation state, stability increases down the groove. Plus 4 stability oxidation state increases down the groove, but plus 6 oxidation state decreases. Plus 6 oxidation state decreases. Sir, why, sir? What is the reason? What's happening here? If you ask, the reason is that due to inert pair effect. Already I told you, inert pair effect means NS2 electrons are not participating in bonding. Okay, this group elements general electron configuration. What is that? NS2np4. Only 4 electrons are participating in bonding. These 2 electrons are not participating in bonding. That phenomena is said to be inert pair effect. Okay, right. And the next, now we are going to discuss about this is the oxidation state. Next, now we are going to discuss about the anomalous properties of 6th group elements of oxygen. Anomalous properties of what is that? 6th group elements of oxygen. You know that oxygen is different from other group of elements. So what is that? See, oxygen is a small size, first one, and highest electronegativity elements only, and highest ionization enthalpy or ionization potential or energy, both are same. Ionizational potential, highest electronegativity. Okay, non-availability of d orbitals. D orbitals are offset. Non-availability of d orbitals. Okay, and see this oxygen, we can say that the bonding capacity or covalency. The bonding capacity or covalency, how much Just 2. Okay, but never exceeds the 2. Rarely exceeds 2. Okay, but other group of elements, covalency exceeds 4. Other group of elements, covalency exceeds 4. Okay, so this is some important anomalous properties of oxygen, right? And the next, now we are going to discuss about these elements reaction with the hydrogen. Reaction with hydrogen. Okay. See, these elements are reaction with the hydrogen, then EH2 type it will be formed. What type? EH2 type it will be. So example, H2O, H2S, H2, Se, H2, tellurium, H2 polonium. See, so this is the reaction with the hydrogens. EH2 type it will be formed. E is the atom, central atom, oxygen, sulfur, selenium, tellurium, polonium. And remember, these are reaction with the hydrogen, then formation of these type of the hydrides. These hydrides, acidic character is important. This hydride acidic character increases. Acidic character increases. Why increases, sir? See, acidic character increases. From where? Acidic character increases. Okay, and see, these hydrides, acidic character increases due to thermal stability decreases. Thermal stability decreases, as well as bond dissociation enthalpy also decreases. Bond dissociation enthalpy also decreases. So bond dissociation enthalpy decreases means acidity down the group increases. That point will remain. And here I want to compare the boiling point of these two hydrides. You remember, H2O is a liquid, H2S is a gas. Once you ask H2O, your liquid, it's a gas. H2O is having highest boiling point. It's a very low boiling point. Very low boiling point. Why? What is the reason? It means that here oxygen is telling that in H2O molecule, oxygen, this molecule is going to exhibit the intermolecular, what? Intermolecular hydrogen bond. Intermolecular hydrogen bond, which is going to exhibit, what is that? Due to intermolecular hydrogen bond, H2O molecule is the highest boiling point than H2S molecule. Then which one? H2S molecule. Okay, right. Now see here. Reducing character. This is a very, very important. Reducing character down the group is increases. Reducing character down the group increases. Yeah. I'm writing that. Reducing character down the group increases. Okay. You remember, H2O, not reducing agent, does not reduce. Water molecule, not reduce. If it is water molecule reduce, it's reduce others, itself undergoes oxidation. It means that oxygen should get positive charge. It's never. Okay, but except the water molecule, the remaining group elements reducing character down the group is increases. Okay, and polonium is a very powerful reducing agent. Okay, so this is the information about the reaction with the hydrogen. Right. Next, now we are going to discuss about the reactivity towards oxygen. Reaction with the oxygen. So these group elements are reaction with oxygen. Then here, what type of oxides are it will be? Two type of oxides, EO2 and EO3 type. EO2 and EO3, these two type of oxides are it will be. Okay, and see, sulfur dioxide is a gas, and O3, ozone also it will become O3, EO2 and EO3, two type of it will become when these are reaction with oxides. And the important point is that here in the EO2 types, sulfur, selenium, and tellurium. Okay, these oxides reducing character decreases. What happens? Reducing character decreases. This oxide's reducing characteristic decreases. Okay, it means that sulfur dioxide is acted as a strong reducing agent. Strong reducing agent. And this oxide as a weak reducing agent. Nothing but strong oxidizing agent. Strong oxidizing agent. Yes. And you see, one more important point of these oxides. There is a EO2 type or EO3 type, whatever the type. EO2 type or EO3 type, all are acidic character. All are acidic character. EO2 type or EO3 type, all are acidic characters. Okay, so now here, this is the reactivity towards oxygen. And the next, reaction with the halogens. Reaction with the halogens. Reaction with the halogens. Okay. Reaction with the halogens. In the reaction with the halogens, these halogens are reacts, then formation of EX6, EX4, EX2, U2X2 type of also forms. What is that? EX6, EX4, EX2, U2X2 type also it will be. Now see, EX6 type we are going to discuss now. EX6 types. In the form of EX6 type, these all are gases. And remember the stability of halogens. The stability of halogens. The stability of halogens. That is the fluorine greater than, bromine greater than. And remember, EX6 type formed by the two stable halides. EX6 formed by the two stable halides, only fluorides. Only fluorides. Fluorides only it will be found. And these all EX6, example SF6. These polar fluorides, these all are gases. And SF6 is the most stable due to some steric reasons. This is the most stable. Okay. And SF6 molecule is a octahedral shape. Which shape? Octahedral shape. And it has sp3d2 hybridization. What is that? sp3d2 hybridization. Okay, right. Now we'll go for the EX4 type. In the form of EX4 type, see, in the form of EX4 type, that is the formed by SF4, SCF4, and PF4. So this type of form. SF4 is a gas. SCF4 is a liquid. And PF4 is a solid. Solid form it will be found. This is a gas. This is a liquid. This is a solid form it will be found. And these are having the wonderful shape. That is a seesaw shape. Okay, and these are having sp3d hybridization. What is that? sp3d hybridization. Next, if you are going to discuss about the EX2 type, in the form of EX2 type, okay, so that is that in the form of EX2 type, that is except to selenium, EX2 is formed by sulfur, SCl2, SBr2, SF2, except selenium. As well as trading amounts of TCl2, TBr2 it will be except to selenium. Okay, so these are the structures. These are the structures. These are having the sp3 hybridization into tetrahedral structure. What is that? Tetrahedral structure. Okay, and the next you see, now the last one is the E2X2 type. E2X2 type. In the form of E2X2 type, these are best example. S2Cl2, Se2Cl2, Se2Br2, okay, S2Br2, these type of compounds are found. So these type of compounds are stabilized by due to participate in the disproportionation reaction. Which one? Disproportionation reaction. So in that, Se2Cl2, 2 moles, then formation of 3Se plus SeCl4 will be formed. So by the disproportionation reaction, E2X2 type molecules are stabilized. Okay, right. Thank you. So we'll discuss now. Okay, thank you. Bye. Hello.